recording at? We are officially recording now. How many people do we have here? Because we only had like 6 to start, I swear. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay. We've got our typical 12. All right. So we're going to finish up 4.3 today. We don't have much left, but we're going to talk about work. So the definition of work is the amount of force and the distance moved. Okay. So if you use a 5-pound force to lift a box from the ground 4 feet, you get 20 foot-pounds of work. Okay, so that's lifting it straight up. Now let's talk about what happens if you're lifting it at an angle. Like, consider a sled being pulled by a child along the ground by a rope. The force vector along the rope is not in the same direction as the displacement vector because he's pulling the dog and the sled forward. Okay, so in this case we're going to use the dot product to find the work. So the definition of work, the work W done by a force F applied along the displacement S. Okay, so he's going in the horizontal direction. W equals F dot S, which equals the magnitude of the force times the magnitude of the distance times the cosine of alpha, where alpha is the angle between the force and the displacement. Okay. So in this case, a child pulls the sled 7 feet. The work done is going to be work equals F dot S, which equals the magnitude of F times the magnitude of S times the cosine of alpha. So that's going to be your 25 pounds times your 7 feet times your cosine of 37 is going to be 140 foot-pounds. So that's basically your nice formula there. Okay. So another example that we can go over really quick, a force of 50 pounds. Actually, before I do that, does anybody have any questions about this kid pulling a sled? No? Good. I have to tell you, it's funny how you start thinking of weird stuff like this. When I was in a physics class, we started like figuring out stuff in our real life, and we were like, man, we're crazy if we're figuring this out. Anyway, force of 50 pounds on a rope is used to drag a box up a ramp that is inclined 10 degrees. Okay. If the rope makes a 37-degree angle with the ground, okay, find the work done moving the box 15 feet on the ramp. Okay. So remember our angle, we're going to have, if we're pulling this up at 37 degrees, we have to take that 37 minus the 10 degrees on the here. So you're really, the difference in your angle is 27 degrees. Okay.
So with that 37 degrees, that's the full between where the force is being pulled and the actual ground, not like the ground of the ramp.
Yeah,
does that make sense? Okay.
The way we've got the picture there, we're drawing that from the horizontal, not from the ramp.
Okay.
So yeah, so you're going to take the 37 minus the 10, you're going to get 27 degrees. Okay. So it's simply going to be the magnitude of the force, 50 pounds times 15 feet times your cosine of 27 degrees, which works out to be 670 foot-pounds. Okay. Does that make sense?
Is this pretty much finding the projection of our steeper angle onto our S? And so that way we're only seeing, I don't know how to describe it.
You can kind of think of it like as a projection, but the thing is, we're just adding the distance into here. So if you're taking 50 pounds, so if you were moving 50 pounds 15 feet in a vertical direction, you would just multiply those two together. And that would be 650 foot-pounds. So because you've got the angle on there, the angle makes the work harder, and so you're going to need a little bit more force to move it up the ramp, which makes sense.
Curious question. Could this same equation be used for calculating torque? Like say if you're trying to calculate torque on a car? Or would that be different?
Because torque is measured in foot-pounds as well, isn't it?
Yeah.
Is that something different?
Was it?
Yeah, it's measured in foot-pounds.
We're not going to talk about torque in this class, but maybe.
I just wonder if
I haven't
torque is
thought
a
about that.
measure of work.
I bet it would if you had like specific parameters. So if you said like how much this engine will have this much torque because it pulls a 50-pound box 15 feet on a 27-degree ramp. Like if there was some kind of industry standard, I bet it would work. I don't know. That's what I think.
Yeah. Good question. I'm not a car guy, so I don't know
Okay.
how that works. But all right. So then anyway, any questions on 4.3? I'll take that as a no. So we're going to move on to 5.1. My notes got messed up on that, so I'm going to I'm going to follow the book. But I think you guys will actually like 5.1 here. So 5.1, we're going to talk about the real number system and imaginary numbers. So remember, the imaginary unit is designated by the letter, that should be a lowercase I, such that I squared equals -1. So if A is a positive real number, then the square root of -A equals I square roots of A. And so we're going to call this an imaginary number. So typically we put the I before the square root so it doesn't get mistaken as being under the radical. So yeah, so that's going to be how we do that. A complex number is of the form A plus BI, where A and B are real numbers, and I is the square root of -1. So A is the real part, B is the imaginary part, okay? So if I have two complex numbers, A plus BI and C plus DI, then A plus BI plus B plus CI, you're just going to add the real parts together, A plus C, and you're going to add the B plus D on the imaginary parts. And if you want to subtract them instead of add them, you will subtract the real parts and you will add the subtraction of the imaginary parts. So you guys are going to like this. You're going to be like, I like this quiz. So let's do some examples here. What if I said I want you to find 7 minus 2i, and I want you to add -2 plus 4i. So let's pick on, we'll start at the top today. Brian Larson, can you add those two together?
Yeah, so it would just be 7 plus -2.
Which is?
5.
5.
And then, sorry, one sec. Sorry, I had something caught in my throat there. And then you take -2i plus 4i, which would be 2i.
Okay. So these aren't too bad, right? What if I said I want you to do -9 plus 4i, and I wanted you to subtract 2 minus 6i. And let's pick on Cameron Daly. Are you on camera, Cameron?
Yeah.
Oh, you are? Okay, I can't see you. How would you do that?
So we do -9 minus 2,
Which is?
-11.
Okay.
And then we do 4i minus -6, which would be 10i.
So is that positive or negative?
Positive.
Plus 10i. And it sounded like you were playing Jeopardy with me again.
It is.
All right. Okay, so you guys love these on the quiz, right? This isn't too bad. All right, so let's talk a little bit about multiplication. If a plus bi and c plus di are complex numbers, then a plus bi times c plus di equals ac minus db plus ad plus bci. Okay. So one of the things that I like to say, you guys have all heard of FOIL, right? And this one you can FLA because the OI drops out. Some of you like the FLA instead of FOIL. So at any rate, let's do a couple of these. If I had 3 minus 4i, and if I multiplied that by 2 plus 5i, who can do this one? How about Cassie?
So we take 3 times 2, so that'd be 6,
Okay.
and then minus -4 times 5, so that'd be -20.
So 6 minus
So that just
20.
becomes a plus.
No, it's actually a minus
Okay.
because there's a plus in the middle there.
Okay.
So you're adding -20.
Okay.
Okay. So that's, you need your I there, of course. Okay.
Yeah. Plus 3 times 5i. So that'd be 15i. Plus 4i times 2. So that'd be 8i.
No, you've 8i. You're right.
Wouldn't it be a minus 8i because it's a -4i times 2?
That's correct.
Yeah.
Okay.
Sorry, I missed the negative.
Actually, you know what? I was thinking you could do that. We're not going to do that yet. I'm going to save that for later. That's for our conjugates.
I have a
Okay.
quick question.
Okay, go ahead.
So, in the formula you have AC minus DB. So wouldn't that be 6 minus a -20? Wouldn't that make it a 6 plus 20i?
Um, 3 times 2 is 6. 3 times 5 is 15. 4 times 2, -8. -4 times 5, -20. This one should be I squared though. Is that what you were saying?
No, I just mean like in the formula above, it has the first it has A times C minus DB. So
Yeah. Honestly, it's probably easier just to FOIL this out, just like Cassie did. Okay.
Does the negative
Now-
come from the I squared? Because I squared is -1, right?
Exactly. That's what I was just going to say. So I squared is
I
-1.
get it.
So this becomes a plus 20. So 6 plus 20 is 26, right? And then 15 minus a is 7i. Okay. So when we look at this, honestly, it's probably easier just to FOIL it out like Cassie did there. Then remember this dumb formula, because I don't think I've ever remembered the formula. But if you want to look at it, a times c, that's going to be 6. And then the reason why it's a minus dB is because I squared is -1. So that's why this minus becomes a plus. And so you get the 26 there.
Oh, okay, cool.
And then AD plus BC. So that's 3 times 2, or AD. 3 times 5 is 15 plus BC. Yeah. So I wouldn't even, I mean, I know this is in the book. Just FOIL it out and remember that I squared is -1. And so then that minus turns up into a plus, essentially. Does that make more sense? I like the way Cassie did it. Then, especially, don't I give you enough stupid formulas to memorize? You don't need to worry about that one. The main thing is just remember that I squared is -1, and so whatever this is, you're going to change the sign. Okay? All right, so let's talk about conjugates. Actually, before we do that, let's do a few examples here. So let's do 3 minus 4i. And we're going to multiply that by 2 plus 5i. Okay? So whose turn is it now? It must be Chris's turn.
You got a visitor. Yep. All right, so you do 3 times 2 is 6. Wait, is this the same as?
Just FOIL it out.
Example.
I don't have to remember that dumb formula.
I was just saying, all right, 3 times 2, so 3 times 5 is 15i. And then -4 times 2 is 8i minus 8i. And then...
Isn't this the same as the last one we just did?
Yeah, this is the exact same.
Oh, this is the same thing. How did I do that twice? Okay, well, we're just making sure you can follow it.
Yeah, okay, sure. Okay.
I didn't realize it did the same thing twice. Finish it off.
Yeah, and then you got -20 I squared.
I squared. Okay, and that's going to equal that one. I didn't realize it did the same one twice. Okay, perfect. Okay, you passed that test well. Okay, how about this one? Oh, do I really want to use the equation editor? Not really, but we'll do it this way. Here, we're going to use the equation editor in this one. Okay, what if I said 2 plus the square root of negative, and I don't know why it does that, -3 times 4 minus 5 square roots of 3. Okay. So Chris just did that one. You got off the hook there. Corey, can you do this one?
Yeah. So we're just gonna FOIL it, right? So it would be 8 minus 10 square roots of 3 plus 4 square roots. Or sorry, okay. So minus 10
we'll do this
square
thing here.
Oh, sorry.
Okay, so 2 times 4 was 8. You got that. And then tell me what to do next.
Minus 10 square roots of 3 plus. Are we wanting to introduce the imaginary number here? So plus 4i square roots of 3.
Okay, yeah. I didn't think this would knock me out of my equation header. 4i square roots of 3.
And then plus 5i square roots of 9, which would end up being 15i.
Because the square root of 9 is 3, right? Okay.
Mhm.
All right, so we can do some simplifying. So this becomes 3 times 5 is 15i. We got a 15i there on the end. Okay.
Mm-hmm. And then you still have the plus 8 at the beginning. And then you have and then you can't. Would you have negative 6i square roots of 3?
So,
Or is it, but you can't simplify those, can you actually?
So I've got 10 plus 4i, 10 plus 4i times
So it would be
the square root of 3.
Yeah, so negative 10 plus 4i, or negative 10 times 4i. No, plus 4. You're right. Sorry.
Oh, except for, yeah.
Negative 10
That's
plus
a negative.
4i.
It's such a pain to write this out here in the thing. Okay. Now, actually, didn't we make a mistake somewhere? Oh, I know what the mistake was. We should have left that as a negative.
Oh, that was supposed to be negative. Okay.
That simplifies this whole thing a lot better, right?
Yeah.
Okay, so now,
because then you would have, that would be,
I squared.
yeah, I squared right there. So it would end up being minus 15, 8 minus 15. So it would be negative 7 minus.
Yeah, so this
and then
becomes
that
a
whole thing.
minus 15 now.
Yeah.
And then,
Simplifies to negative 7. And then plus 10.
wait,
or plus,
actually, is that true? You know what? Let's do this again because I swear the problem is I wrote the problem down wrong. Let me make sure I got the problem right here. 2 plus negative square root of negative 3, 4 minus 5 times the square root of negative 3. Okay. So 4 times 2 is 8. And then I've got plus 4 square roots of square root of negative 3. It doesn't like that. Negative 3. 5 minus 10 square roots of negative. And then negative square root of 3 times negative square root of 3 is negative 5. So negative square root of 3 times negative square root of 3 is negative 3. Right?
Yep.
Okay. So then this becomes 8 plus 15 is 23. If I take that term there.
And then minus 6 square roots of 3. Or minus 6i square root of 3.
6i square roots of 3.
It would be a minus 6i, right? Since it's 4 minus 10.
Just a second. Square root of 3. Yeah, it's negative. You're correct.
Okay.
Okay.
Yeah, that looks a lot better.
Yeah. So it helps if you write the problem down right. Okay. Now, does everybody see what I did there? The square root of negative 3 times the square root of negative 3 is just plain old negative 3. Okay? All right. Okay. So let's talk about complex conjugates. Complex conjugates, okay? So the product of a complex number and its conjugate is a real number. That is a plus bi times a minus bi equals a squared plus b squared. And I'm going to fix my thing here. Okay, so then I gave away my thing here. What I meant to say was you can FLA instead of FOIL because the OI drops out, because you're going to get a times bi, and then you're going to get negative bi times a, and so then the inside and the outside drops out. So you can FLA. So this becomes a squared plus b squared. Okay, because when positive b times negative b, you'd think that would be a negative b, but I squared is negative 1, so then it flips the sign, so then it becomes positive. Okay? So we use conjugates to when we need to divide. Okay? So for example, if I wanted to simplify the following equation here, okay, let's say that I had a fraction, okay, I've got 16 minus 11i, and I want to divide that by 5 plus 2i. Okay. Now we don't have any good ways of dividing those directly, and so what we're going to do is we're going to multiply by the conjugate of the denominator. So as I'm building my equation here, what is the conjugate of the denominator? Graham.
It would be 5 minus 2i.
No more Jeopardy for you, Money.
Nope.
Okay, so we're going to multiply. I can tell that you guys really must love that show. Okay, so I've just multiplied this by 1, correct? Okay. And so when I'm doing this, what's nice about it is, tell me what the bottom is first.
Let's see. It would be, let's see, those 2 i's would cancel out. So it would be 25 minus, or no, plus 4? No.
Oh, yeah. Well,
Is
you
that
went
right?
straight for there. You could have done minus 4i squared, but then it would have been plus 4. Okay.
Yeah. Okay.
So you've just turned your denominator into a real number, which is pretty cool. Now we've got to FOIL out the top. So so on the bottom we can FLA, but on the top we need to FOIL. Okay. So can you help me FOIL that out?
So it would be 16
16
times
times 5,
5.
which is 80.
So 80 minus 32i minus 55i plus 20, well, minus 22.
Well, let's be careful about this. So negative 11 times negative 2 is positive 22.
Yep.
But then I've got an I squared. Oh, I was hoping that would work that way. I squared. Okay. So when we simplify that again, on the bottom
of 29.
There we go.
Wouldn't
We've
it be
got
minus
29.
55i?
Oh, yeah. Thank you. So on the bottom, we've got 29. On the top, we've got, so 22i squared is going to be negative, right?
Yep.
Negative 22. So 80 minus 22 is
58.
No, 80 minus 22. Yeah, 58. And then minus 32 minus, or negative 32 minus 55 is negative 87i. Okay. So here's the amazing thing about this. Those all are divisible by 29. So 58 divided by 29 is just simply 2, right? And 87 divided by 29 is actually 3i. Okay. So we've just divided this to get 2 minus 3i. Okay. Does that make sense? All right. So, now, the last thing that I want to talk about today is let's figure out. So we know that I better go back to my equation editor. It's going to capitalize that every time. We know that I equals the square root of negative 1. Okay. Oops. Negative 1. And we know that this is where I hate this thing. You know, I've got a math editor in here, and I've got a different math editor in Canvas, and I think I like the Canvas one a little bit better. I squared is negative 1. We know that. What's I cubed?
Negative 1 times the square root of negative 1, or negative 1i.
Yeah, so I cubed would equal I squared times I, right?
Right.
Okay, and if I squared is negative 1, then this equals negative I. Okay, and then I to the fourth what's I to the fourth?
It's I squared times I squared, which is just 1.
And I'm going to cheat and I'm going to copy this. I squared times I squared. So that's negative 1 times negative 1, which equals 1. And then finally, I to the fifth, just for fun. I to the 5th equals I to the 4th times I, right?
Right. It's
And I to the
square root
4th is
of
1,
negative
so that just equals I, so we start over.
Right.
Okay. So you can see here that every 4th, I don't want to call it a root, 4th exponent, it repeats. Okay. So what if I told you to find I I to the 153rd power. Oh my goodness. What happened to my thing? How would you find that?
Just guessing, but would you just take that last number, the 3, and it'd be negative I? Or am I way off?
You're on the right track, but you're off.
But I don't know what else to do.
Okay. So remember that these repeat every 4, right?
So take 153 divided by 4.
153 divided by 4. Now we're going to have to do this longhand, right?
Right.
Can I do this way? Let me see here. Where's my division sign? Do I have one of those? I don't. Okay, I'll leave this the way I had it before. Okay, so 153 divided by 4. In this case, 4 goes into 15.
3 times.
4 times 3 is 12. Bring down the 33. So 4 goes into 33. 4 times 8 is 32. And then I'm going to have a remainder of 1. Does that make sense?
Yep.
Okay. So essentially, I to the 153rd equals
I to the 1st.
I to the, where am I at? Equation error. Okay, so I could do this as to the 4th to the, and then this whole thing to the 38th power, which all of that is just going to be 1, right? Because I to the 4th is 1. So I've got
Right.
1 to the 38th power times I. So that's just going to equal I. Does that make sense, Nicole?
Ish.
Ish.
Is it?
So essentially what I've done here, I've raised I to the 4th to the 38th power. So basically all you need to do, take the exponent, divide it by 4. You're going to get whatever the number is, but it's the remainder is what you care about.
Oh, okay.
So since I have a remainder of 1, that's I to the 1st power. And of course, I to the 1st power is just the square root of -1, or I.
Okay, that makes sense.
Okay.
Thanks.
So yeah, so this is the one. Maybe I'll highlight this in yellow because that's our favorite one. Because basically, out of the fourth is 1, so that 1 to anything, any power is still 1, and then all you care about is the remainder. Okay. All right. So, any questions that you guys have for me?
Nope.
So we were able to finish 4.3, the work, and 5.1. So your quiz on Monday is going to be, I'm going to give you a good work problem, like one of these 2 problems here. Your answer will more than likely be in foot-pounds. I think if we use metric units, they use newtons. But yeah, a newton is basically meter kilogram, if I remember right. And chapter 5.1, section 5.1. So, all right. So, you all good? Okay. So just a quick reminder. This is your last Thursday without a test. So next Thursday we will have a test. The second Thursday we will have a final exam. So I'll give you, so the final exam I'll give you the full 2 hours. But yeah, so next week we'll just plan on a 90-minute test. So any comments, questions, complaints? No? Okay. I'll let you guys go, and then you guys want to stick around for Texas's meeting. I think that's a great idea. Did we lose anybody? We lost some people. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Who did we lose? I don't remember. But anyway, you people are missing out if you're not sticking around. All right. Have a great weekend and enjoy your last test-free weekend for 2 weeks.
Yay.
Have a good one.
See ya.
Thanks, you too.